So a set is a collection of objects. It's an unordered collection. It doesn't matter how you list them. And the objects inside the set are called elements. So the members of the set. The way we note this is if X is an element of set A, then we say X, and we use this element of or in set A. And if X is not an element of set A, then we use a very similar symbol. We just put that slash line through it. So the order doesn't matter. The elements can be anything. You could have the set of states in the US. You could have a set of numbers. You could have a set of names. The two sets will be considered the same if they have the same elements. So if I write this set 1, 2, 3, 4, and then I write this set 4, 3, 2, 1, same. If I write this set 1, 1, 2, 2, 3, 3, 4, same, because we don't care about how many times they appear. We just have a list of elements there. So there are two ways to describe a set. One is a roster method, which is just a list of all the elements in curly braces. That's kind of what I showed you, those examples. So if A, B, and C are elements of set S, then we would say S is, curly braces, A, comma, B, comma, C. Another way to list the elements is using set builder notation, but I want you to remember that when you're listing elements, we ignore order and we ignore duplicate elements. So when we do set builder notation, we sort of describe the elements that are in the set. And so we could say X in D such that P of X, where D is the domain I'm picking my elements from, and P of X is the predicate that they satisfy. So think about your predicate logic that we did. So if I said the set of all X in Z such that -2 is less than or equal to X is less than 4, that's set builder notation. The elements that you're choosing come from the integers, and they have to satisfy the predicate that the X is between -2 and 4. So if I was to list this in the roster method, it would look like -2, -1, 0, 1, 2, and 3. So I want to just do a couple of examples. Here are some sets described in set builder notation, and we want to write them in the roster method. And I want you to notice that they're sort of written in two different ways. The first example tells me the predicate it satisfies, and then it tells me where to get the elements from, while the second example tells me the domain and then tells me the predicate. So in the first example, all of the elements in the set are going to look like 3 times n plus 1, where n is a natural number. So if you remember, the natural numbers were the integers 1 and bigger. So if n was 1, my first element would be 3 times 1 plus 1, 4. If n is 2, my second element is 3 times 2 plus 1, 7. If n is 3, my third element is 3 times 3 plus 1, 10. We use these ellipses, these 3 dots, when we have a pattern and it's going to keep repeating, but it never ends. Okay, the second set I said the X and Z, so integers, such that X squared is less than or equal to 4. So think of all the numbers, all the integers you can square, that they'll be less than or equal to 4. So you could square 0, you could square 1, but you could also do -1, because when you square -1, it's less than 4. you could do 2, and you could do -2. And notice I didn't list them in order that time. I just listed them as they came to us. Okay, so in the last example, we have 2 sets that are in roster method, and we want to write them in set builder notation. So there's lots of different ways. There could be many answers. For this one, A equals 1, 2, and 3. You could say all the integers such that positive 1 is less than or equal to x is less than or equal to 3. That's not the only way. You could say x and z such that the 0 is less than x is less than or equal to 3, right? So there's a lot of different ways that you could describe the same set. Okay, B. These look like negative numbers, but only even ones. So even negative numbers. And notice that this set goes on forever. So I could say B is the set of all x and z, the set of all integers, such that x is less than or equal to 0, and x is even. There's one way to describe it. I could say -2 times n, such that n is a natural number, and that would give me the same set.